These are the Chapter 3 review notes. Make sure you're filling in your guided notes as I go through them. First couple of things that we covered in this chapter: inductive and deductive reasoning. Remember, keywords. Keyword for inductive reasoning, that's just when you're using patterns to draw some kind of conclusion. Deductive reasoning uses rules, facts, all the theorems, postulates, all that stuff. So inductive patterns, deductive uses rules. Conjecture is just a statement. Could be any statement, and it could be either true or false. Remember, when they ask you to find the truth value of something, that's just asking you to tell whether it's true or false. So don't make that harder than it is. That's all a conjecture is. Counterexample, sort of important. Make sure you can find a counterexample. Counterexample is just something that shows that a statement is not always true. Not an explanation. It's usually just an example. If I say all numbers are whole numbers, then your counterexample might just be you write down 1/3. That's a counterexample. Doesn't have to be an explanation, just an example that shows that a statement's not always true. Be able to find and explain patterns. So if I give you a pattern, be able to find it, and not only find it, if I give you a pattern like this, if that's my pattern, then be able to find the next numbers in the pattern, however many they ask you to find, and be able to explain what you're doing, something like your add one each time or whatever. But be able to explain it. Remember, negation is just sort of put not in a sentence. And you got to be careful with that, because if it's already a negative sentence, then it's going to change it to a positive sentence. So an example would be something like if I say it is raining outside, the negation would be it is not raining outside. But if my statement was, it is not snowing outside, then the negation of that would be, it is snowing outside. This is the symbol for a negation. So you see something that has that symbol and that says Joe, that just means not Joe. Other things that we covered: conjunctions and disjunctions. Remember, conjunctions use the word and that's the symbol. That TP looking thing is the symbol. The upside down V is the symbol for a conjunction. So if I say something like geometry and then that symbol, fun, then this means geometry and fun. With a conjunction, remember, with a conjunction, both parts of the statement have to be true for the whole statement to be true. So if my statement said, something like 2 plus 2 equals 4, and then that symbol, and then 2 plus 1 equals 4. This part's true. This part's false. Since only one of the parts is true, if it's a conjunction, then that means the whole thing has to be false. So both parts have to be true for the whole thing to be true. A disjunction uses the word or. So if I change this symbol right here and made it a disjunction, put that in there, it'd say 2 plus 2 equals 4, or 2 plus 1 equals 4. For a disjunction, only one part has to be true. So up here for a conjunction, both parts got to be true. Here, only one part has to be true for the whole thing to be true. So when we got done, if this was our statement, using the word or in there, then that would be a true statement. So conjunction, and, uses the word and, both have to be true for the whole thing to be true. Disjunction uses the word or, that's the symbol, and only one part has to be true for the whole thing to be true. Conditional statement, remember another name for a conditional statement is an if and then statement. The if part is the hypothesis, the then part is the conclusion. So we might have something like if right angle, then 90 degrees. The hypothesis is the right angle, not the if, but just the right angle. The conclusion is 90 degrees. Once we had conditional statements, don't forget, a lot of times we'll tell whether they're true or false. And you have to be able to write statements that aren't conditional as a conditional statement, so using the words if and then. And then also we learned how to write the converse, inverse, and contrapositive. Converse, remember, just switches the hypothesis and the conclusion. So if we were going to do these for this statement right here, it would switch it around and it would say if 90 degrees, then right angle. The inverse, don't forget to always go back to the original statement. The inverse just negates both parts. So it would say if not a right angle, then not 90 degrees. And you would probably have to tell whether each one of these are true or false. The first one here, if it's 90 degrees, then it's a right angle. Well, that's true. If it's not a right angle, then it's not 90 degrees. Well, that one's true also. Just happens to be the one I picked. All these are going to be true. And then the contrapositive switches and negates. So it would say if not 90 degrees, then not a right angle. And that would also be true. So make sure you can do the converse, inverse, contrapositive. Guarantee there's at least one problem on the test, and it counts quite a few points because you got to do all this stuff. You got to find the converse, inverse, and contrapositive of that statement and tell whether it's true or false. Biconditional just means that the original statement was true and the converse is true, then a statement's considered biconditional. Remember, this arrow means implies, so we might write something like right angle implies 90 degrees. Well, this time we could say if it's a right angle if and only if. Both are true, so we could actually use the double arrow there because it works both ways. If we know it's 90 degrees, then it has to be a right angle. If we know it's a right angle, then it has to be 90 degrees. Law of detachment. Please don't make these harder than they are. Law of detachment. Remember, they're going to give you one full sentence, one full conditional statement. It's going to say if P, then R. If we know this is true, and we separate, we detach the hypothesis, and say we know that P all by itself is true, then we can say, we can detach the conclusion and say it all by itself is true. So if I say something like, if Toad, then dog, just making up stuff here. This is our hypothesis, this is our conclusion. And I tell you that that statement is true, and I tell you that Toad all by itself is true, then we can come up with the conclusion that dog all by itself must be true. Law of syllogism. Law of syllogism just says if P then R, if that is true, and then if R then M, if that is true. So they give you two whole conditional statements. Notice that the conclusion in the first one's the same as the hypothesis in the second one. It has to be that way. If it's not that way, then it won't work. And what we can do, if these two are the same, then we can take the hypothesis from this statement and the conclusion from this statement and put them together, and we know that that statement has to be true. So we can say, if P, then M. So we could say something like, if movie, then money. So if we want to go to the movie, we got to have some money. If we need money, then job. And from those two statements, the conclusion that we can draw, since this conclusion is the same as this hypothesis, we can just put these two parts together and draw a conclusion that that has to be a true statement. And we can say, if movie, then we need to have a job. If we want to go to the movie, then we need to have a job. Different things to know. Make sure you know all the postulates and theorems. Some examples, sigma addition postulate, we use that quite a bit. All right angles are congruent, vertical angles are congruent. Those are ones that we use quite a bit. There are others, and we'll probably try to have them over on the board again. Other things that we use quite often. So make sure you know those. And the definitions, and we'll have some of those on the board too. You know, like a linear pair. If you have a linear pair, that's two angles that together add up to a straight angle, add up to 180. No supplementary, complementary, midpoint, collinear, reflexive property. Please don't write reflexive property anywhere. Remember, reflexive property says anything equals itself. Know that this upside down T here means perpendicular. As soon as you see perpendicular, you should think of things like right angles, 90 degrees, so on and so on. Supplementary and complementary, going back to those, remember supplementaries, two angles that add up to 180. Complementaries, two angles that add up to 90. So make sure you know all those different definitions and theorems, postulates. Other things, I'll give you a minute to write some of this down here in a second. Make sure you can do the algebra proofs. Those were sort of the easy ones, knowing all the properties. Remember that when you're doing something to both sides, like let's say you're adding something to both sides, it's addition property of equality. It's gotta have that last part on it, or it won't be right. Also make sure you do not abbreviate subtraction, SUB. Make sure you write out at least subtract. So it'll be subtract property of equality. Substitution, same thing, make sure you write it out. The different other two column proofs that we did, ones with segments. Some key things to remember: segment addition, midpoint, definition of congruency. Remember, definition of congruency is just when you switch from algebra to geometry, or geometry to algebra form. Some of the stuff that we did with angles, make sure you know that an angle bisector, if I have this angle, an angle bisector splits it into two congruent angles. Remember that supplementaries add up to 180, we just talked about that, complementaries add up to 90, and then the angle addition postulate just says if I have something like this, I know that this angle, angle 1 here, and angle 2, that's supposed to be a 2, those two angles add up to be this entire angle. Get out the packet, and we'll do as many of them together as we can in between now and the end of class.